Hello, science fans. Whether you're a curious student, a future engineer, or just someone who loves to know how things work, you're in the right place. Today, we're diving into the fascinating world of three-phase power, the invisible force that keeps factories humming, skyscrapers glowing, and maybe even the building you're sitting in powered up and running smoothly. To understand why three-phase power is so important, let's start with something familiar. Imagine riding a bicycle with just one pedal. It would be jerky, awkward, and you'd have to work extra hard to keep moving. That's a lot like single-phase power, which is what you find in most home outlets. Good for small appliances, but not ideal for heavy-duty work. Now, picture a bike with three pedals, each spaced perfectly apart. As you pedal, there's always one pushing, giving you a smooth, constant ride. That's the magic of three-phase power: steady, reliable, and incredibly efficient. This means that big machines, data centers, and even entire office buildings can run powerful equipment without interruptions or flickers. It's the backbone of modern industry, making sure everything operates at peak performance. It's the silent powerhouse of the modern world, working behind the scenes to keep our cities bright and our technology running. But where does this three-phase power come from? It all starts at the power plant. Giant generators spin with the help of steam, water, or wind, and inside they use three separate coils to create three distinct waves of electricity, known as phases A, B, and C. These waves are perfectly timed, each one peaking just after the other, so there's always a steady flow of energy. Unlike single phase, where the power rises and falls, three-phase keeps things moving smoothly. This staggered sequence is what makes three-phase power so smooth and reliable. It keeps conveyor belts moving, lights shining steadily, and motors running without a hitch. The electrical grid isn't just one big wire carrying electricity. It's a carefully designed network with multiple currents working together in harmony, ensuring that power gets where it's needed, when it's needed. That's why three-phase is the global standard for transmitting and distributing electricity. It's used in nearly every country, making it the universal language of power. From the moment electricity is generated all the way to large buildings and factories, it usually travels in this three-phase form, ensuring maximum efficiency and minimal loss. So, next time you see those transmission towers with multiple wires stretching across the landscape, think of them as superhighways, carrying three powerful lanes of energy to every corner of our world. Three-phase power keeps our world running efficiently, quietly, and reliably day and night, in ways most of us never even notice. Understanding how it works is the first step to unlocking the secrets of the electrical grid and appreciating the engineering marvels that power our lives. So, let's take a closer look at how these three phases connect, interact, and ultimately power everything around us, from the smallest gadget to the tallest skyscraper. Now, let's dive into how three-phase electrical systems are connected, specifically the two most common methods, delta and Y. These two configurations are the backbone of modern power distribution, each with its own strengths and ideal uses. Understanding how they work is key to grasping how electricity is delivered safely and efficiently to everything from massive factories to your neighborhood coffee shop. The delta connection links three windings end to end, forming a closed loop that looks just like the Greek letter delta, a triangle. This setup is simple but powerful, and it's been used for decades in heavy industry. In a delta system, you get three main wires, each coming from a corner of the triangle. There's no central point, so you won't find a neutral wire here, just three robust phase wires carrying high voltage. Delta is perfect for big, balanced loads. Think of giant motors running conveyor belts, pumps, or compressors in factories. It's designed to deliver lots of power efficiently, making it the go-to choice for heavy-duty industrial applications. However, delta isn't ideal for powering smaller, single-phase devices like lights, computers, or office outlets. Without a neutral wire, it's tricky to get the lower voltages these devices need. That's where the Y or star connection comes in, a clever solution for more versatile power needs. In a Y system, one end of each winding is joined together at a single central point, forming the star. The other ends connect to the three phase wires, A, B, and C. This central point is where the neutral wire comes from, and it's a game changer. The neutral allows for both high and low voltage options from the same system. The Y system is incredibly versatile. It can power large industrial motors just like delta, but it also easily supplies everyday appliances, lights, computers, and more by providing a safe, lower voltage through the neutral. By using just one phase and the neutral, you get a lower, safer voltage, perfect for sensitive electronics, office lighting, and home appliances. This flexibility is why Y is so popular in commercial and residential settings. That's why you'll find Y connections everywhere, from towering office buildings to quiet suburban neighborhoods. It's the standard for delivering reliable, adaptable power to a wide range of users. With Y, a single electrical panel can safely power both heavy machinery and delicate electronics, all at the same time. It's the ultimate all-in-one solution for modern power needs. The neutral wire is the secret ingredient that makes this possible, acting as a bridge between high power and everyday convenience. So, remember, Delta is built for heavy-duty jobs, powering massive machines with raw energy. Y is designed for mixed-use environments, offering both muscle and finesse. Two teams, one goal, delivering the right power in the right way exactly where it's needed. Whether it's lighting up a city or driving a factory, Delta and Y work together to keep our world running smoothly. Let's take a closer look at the Y system's secret weapon, the neutral wire. While it might not get much attention, the neutral is absolutely essential to the way our electrical systems work, quietly ensuring everything runs smoothly behind the scenes. The neutral acts as the return path for electricity, much like the wire that completes a simple battery circuit. Without it, the flow of electricity would have nowhere to go, and our devices simply wouldn't work. In a perfectly balanced Y system, the three-phase currents, each flowing through their own wire, meet at the central point and cancel each other out. This is a beautiful example of symmetry in engineering. Imagine three people pulling equally on ropes tied to one spot. If they all pull with the same force, the center stays perfectly still. That's exactly what happens with the neutral point in a balanced system. In this ideal balance, no current actually flows through the neutral wire. It's as if the wire is just waiting, ready to step in if needed, but otherwise staying calm and quiet. The neutral point is also grounded, anchoring the system's voltage to zero. This grounding provides a stable reference for the entire electrical system, keeping voltages predictable and safe for everyone. Thanks to the neutral, we can safely create lower single-phase voltages for everyday devices, like the outlets in your home, which power everything from your phone charger to your refrigerator. For example, in North America, you'll find 208 volts between two phases, but just 120 volts between a single phase and the neutral. This flexibility is only possible because of the neutral's unique role. The neutral is more than just a wire. It's the anchor and safety valve of the entire Y system. It keeps everything grounded, stable, and safe, acting as a silent protector. Without the neutral, single-phase power wouldn't be possible or reliable. It's the reason your lights don't flicker and your appliances work as they should. And when the electrical loads aren't perfectly balanced, which is almost always the case in real life, the neutral wire steps in, carrying the difference, and keeping everything running smoothly and safely. It's the quiet guardian of the grid, always ready to keep things safe no matter how much the demand changes or how uneven the loads become. But what happens when things aren't perfectly balanced and the neutral has to work overtime? Let's explore the challenges and risks that arise when the system is pushed to its limits. Picture a traffic roundabout with three roads, A, B, and C, each sending cars in at the same rate. The roundabout flows smoothly, never congested, just like balanced three-phase currents canceling at the neutral point. Now imagine a fourth road, neutral lane. In perfect balance, no cars use neutral lane, it stays empty. That's what happens in a balanced Y system. The neutral wire carries no current. Power companies strive for this balance because it's efficient and reduces energy loss. When the system is balanced, wires only carry the necessary current, not extra slosh. This harmony allows the grid to operate at peak capacity. The neutral is always there, ready if needed, but ideally it's just a silent backup. Balancing loads is fundamental to efficient power delivery. But what if the balance is lost? Let's see how the neutral saves the day when things go off kilter. In reality, loads are rarely perfectly balanced. Imagine our roundabout suddenly, Road A sends in a parade of cars while B and C have just a few. The roundabout clogs, just like unbalanced electrical loads create leftover current. This leftover or unbalanced current can destabilize voltages, risking damage to sensitive equipment. A computer expecting 120 volts might get 150. Disaster. Motors on lightly loaded phases might not get enough voltage to run. The system becomes unstable and unreliable. Here's where the neutral wire shines. It provides a safe escape route for the unbalanced current, keeping voltages stable. The neutral acts as a pressure release valve, protecting equipment and ensuring reliability. Without it, the system would be chaotic and dangerous. The neutral wire is essential for safe, stable power, even when loads are unpredictable. That's why it's the unsung hero of the electrical grid. The neutral wire is crucial for both powering devices safely and grounding the system. In commercial buildings, you get 208 volts between phases. Great for big machines. But your toaster or computer needs just 120 volts, which you get between a phase and the neutral. The neutral completes the circuit for these everyday devices. Without it, plugging into two phases would destroy your appliance. The neutral is bonded to ground at the main panel, keeping its voltage near zero. This connection ensures that metal casings of appliances stay safe. If a fault occurs, like a wire touching the casing, the ground-neutral bond allows a surge of current to trip the breaker instantly. This prevents the appliance from becoming dangerously energized. The neutral's connection to ground is a life-saving safety feature. It's the backbone of both convenience and protection in our electrical systems. Let's clear up some dangerous myths about the neutral wire. First, it's not always safe to touch. Neutral carries current, especially with unbalanced loads. If the neutral breaks, it can rise to full phase voltage. Touching it could be fatal. Always treat the neutral with the same caution as a live wire. Another myth. The neutral is less important or can be smaller than phase wires. In fact, with modern electronics, the neutral can carry even more current due to harmonics. That's why codes require neutrals to be as large as phase wires, sometimes larger. Never confuse neutral and ground. They're only connected at the main panel. Using ground as neutral is a massive shock hazard. Keep them separate everywhere except the main panel bond. Working with neutral wires demands extreme caution. Always assume any wire is live. Test with a proper multimeter, not just a voltage pen. Check between phase and neutral, phase and neutral and ground. Follow lockout/tagout procedures. Turn off, lock, and tag the breaker before working. Always verify wires are dead before touching. Be extra careful with shared neutrals. Turn off all circuits sharing the wire. Use insulated tools and proper protective gear. Never take shortcuts. Electrical safety is non-negotiable. Understanding the neutral's role is key to staying safe. When in doubt, call a qualified electrician. Your safety is worth it. Let's wrap up. Three-phase power is the efficient backbone of our world, and the neutral wire is its unsung hero. Delta connections power big balanced loads. Y systems, with the neutral, bring flexibility for everything else. The neutral is the common return path, stabilizing voltages and enabling safe single-phase power. In perfect balance, the neutral is quiet. When loads shift, it keeps the system safe. It's essential for both powering devices and protecting us from electrical hazards. Remember, the neutral is not always safe to touch, must be sized correctly, and is never interchangeable with ground. Respecting these principles and following safety procedures is vital. The neutral wire is a brilliant feat of engineering, powerful, essential, and deserving of respect. Science is everywhere, even in the wires in our walls. Thanks for joining us on this electrifying journey. Stay curious, stay safe, and keep exploring the wonders of science.